Hello friends, welcome to my channel. We are going to solve some problems related to limits. So we are going to discuss about the limit of a function for class 11th. When the given function is not in indeterminate form, limit can be evaluated by directly using the definition of limit or putting value of limit. No method is required in this case, just case the definition of limit. For example, limit x tends to 2, x plus 1 can be find out putting the value directly, and this can be equals to 2 plus 1 equals to 3. So this is not in indeterminate form. What are indeterminate form? The indeterminate form are 0 upon 0, second infinity upon infinity, third 0 into infinity, 0 into infinity, fourth infinity minus infinity, and fifth 1 into infinity, 1 raised to power infinity, 0 raised to power 0, and infinity raised to power 0. These are indeterminate forms. These are indeterminate forms. If in case of limits, indeterminate forms comes, then there are different methods to evaluate the limit in case of different indeterminate forms. But in all cases, our motive will be to get rid of the indeterminate form. After getting rid of the indeterminate form, we use the definition of limit or directly put the value. So again, if a function fx is continuous at x equals to a, then limit of function f at x equals to a can be directly obtained by putting a in place of x in fx. So for example, limit x tends to a 1 x square minus 1 upon x minus 1. This is 0 by 0 form. If we put the value, so we get rid of, this is indeterminate form of 0 by 0 form, so we get rid of this indeterminate form. So for getting rid of indeterminate form, we what we get, the we cancel out the factor x minus 1, and this factor, this can be factorized at x minus 1 x plus 1. And again, this is not in any indeterminate form, and we can put the value of limit. So this is the 1 plus 1 equals to 2. So we have find out our limit. Again, moving on, next situation, we have some formulas. The formulas are limit theta tends to 0 sin theta upon theta equals to 1, limit theta tends to 0 cos theta equals to 1, and limit theta tends to 0 tan theta upon theta equals to 1. So again, we have another formula. We will prove this formula in other videos, but we are going to discuss only some problems here, and we will see here that how can we solve these problems. Again, we have some useful formula. The next useful formula is limit x tends to a x raised to power n minus a raised to power n upon x minus a equals to n a n minus 1. This is also very usual formula, and we always come across with this formula in the problems. So again, we have another formula is limit x tends to, we have another formula is limit x tends to 0 e raised to power x minus 1 upon x equals to 1. This is also an important formula of limit. Again, limit x tends to 0 ax minus 1 upon x equals to log e base of ea or ln a, natural log of a. This is an important formula. So we have seen that we have some important formula in this video. Again, we are going to solve some problem on the basis of this formula. This video is useful for class 11th. Again, using this formula, we are going to use this solve some problems. So we have problems are, first problem is limit x tends to 0 x square minus 5. We are looking here that x square minus 5 is a polynomial, and at x equals to 0 it is defined, so we can put this value directly and can get the limit, and this becomes minus 5. Again, this is also a polynomial, at x equals to 2 it is defined, and there is no any indeterminate form of 7 determinate form that we have this indeterminate form. The indeterminate forms are here. 7 indeterminate form: 0 upon 0, infinity upon infinity, 0 into infinity, infinity minus infinity, 1 upon 1 raised to power infinity, 0 to 0, infinity to infinity raised to power 0. So we are looking here that the given limit is not in any indeterminate form, so we put directly the value of the limit and we get the answer. This becomes x equals to 2 to 2 raised to power q, 5 into 2 raised to 2a square minus 7 into 2 plus 1, and this becomes 8 plus 20 minus 14 plus 1, 6, 15, and this is the answer. Again, putting the 0 value, this is also not in indeterminate form, and so we can get the limit by putting the value x equals to 0. So again, this is 0 cube minus 6 into 0 plus 8 upon 0 minus 2, and this becomes 8 upon minus 2, and the limit is minus 4. So the answer is minus 4. Answer is minus 4. Again, we are getting here, if we put the value x equals to 5, this is also defined, so we are getting limit by putting x equals to 5. This becomes 14 into 5 plus 49, and this is 25 plus 70 plus 49, and this is equals to 4, and this is 14, and this the square root of 144 equals to 12. So again, we are going to find out the another limit. The given problem is determine the limit algebraically if it exists. We know that x minus 6, square root x minus 6 is defined for x minus 6 greater than 0 and x greater or equal to 6, but x equals to 4, x tends to 4, and this function is not defined at x equals to 4, so the limit does not exist here. Limit does not exist. Limit does not exist. Again, we have the problem is limit x tends to 7, mod of 7 minus x upon 7 minus x. So we have problem is limit x tends to 7, mod of 7 minus x mod of 7 minus x upon 7 minus x. So we are going to discuss about this limit. So we are going to find out first of all left hand limit LHL, and we denote LHL at limit x tends to 7 minus, and this becomes for x less than 7 mod of 7 minus x is x less than 7 mod of 7 minus x is positive. So this is 7 minus x. So this is 7 minus x upon 7 minus x, and this limit, this is get cancelled, and this limit x tends to 7 minus 1 equals to 1. So this is the left hand limit, and the right hand limit at x equals to 7 limit x tends to 7 plus, this means that this is the value of x at the 7 from the right side, and this at the x equals to 7 from right, 7 mod of 7 minus x for x greater than 7, this becomes negative, and this becomes negative, and this becomes minus 7 minus x upon 7 minus x, and this value limit x tends to 7 plus, and this get cancelled, and minus 1 equals to minus 1. We know that the limit exists at a point if left hand limit and right hand limit are equal, but here LHL at x equals to 1 at x equals to 7 is not equals to RHL at x equals to 7, and this limit becomes x equals to 1, and this is minus 1. So this is not equal, so limit x tends to 7 mod of 7 minus x upon 7 minus x does not exist. Again we have another problem. What is the another problem? Limit x tends to minus 6 x square minus 36 upon x plus 6. So we have given problem that limit x tends to minus 6 x square minus 36 upon x plus 6. If we put x equals to minus 6 in numerator, this becomes minus 6 square minus 36 equals to 36 minus 36 equals to 0, and denominator minus 6 plus 6 equals to 0. So this limit in 0 by 0 indeterminate form. So we remove this indeterminate form in any case. And how can we remove? By cancelling the factor for which this becomes 0 upon 0. So limit x tends to minus 6, and this can be written as, by factorizing numerator, this becomes x plus 6 into x minus 6, and this becomes x plus 6. So x plus 6 goes to cancel out, and limit x tends to minus 6 x minus 6 equals to minus 6 minus 6 equals to minus 12. So we have found the limit of the given problem. Again we have another limit. Another limit is limit x square plus 15x plus 15 upon x plus 10. So we have problem limit x tends to minus 10, x tends to minus 10 x square plus 15x plus 50 upon x plus 10. Putting the value, we know that the above is minus 10 square plus 15 minus 10 plus 50, and this becomes 100 minus 150 plus 50, and this is 0, and in denominator minus 10 plus 10 equals to 0. So this limit is 0 by 0 indeterminate form. So we remove this indeterminate form. We remove this indeterminate form by cancelling out the factor x plus 10. So we are going to factorize this limit. So limit x tends to minus 10 x square plus 5x plus 10x plus 15 upon x plus 10, and this becomes limit x tends to minus 10 x plus 5 into x plus 10, and this x plus 10, and this x plus 10 gets to be cancelled. Again limit x tends to minus 10 x plus 5, and this becomes minus 10 plus 5 equals to minus 5. Thus we have find out the limit of the given problem. Again we have another problem is limit x tends to 0 x cube plus 12x square minus 5x upon 5x. So we are going to find out the limit of the given problem is a limit x tends to 0 x cube plus 12x square plus 12x square minus 5x upon 5x. So putting the value of x equals to 0 in numerator, we are getting 0, and in denominator we are also getting 0. This is 0 by 0 indeterminate form. So again this is limit, we remove this indeterminate form, by cancelling out the factor of for which this becomes 0 upon 0. So we have x square plus 12x minus 5, we can write it as this also, and this can be x 5x. Since this goes to 0 means this goes either from right side or left side, so x is not equals to 0 here. Again we are, so limit x tends to 0 x square plus 12x minus 5 upon 5. Thus we can, this is not in any indeterminate form, so we can put the values of value x equals to 0 in the limit directly to get out the value of the limit. So 0 square plus 12 into 0 minus 5 upon 5, and this becomes minus 5 upon 5 equals to minus 1. Thus we have solved this problem. Again we are going to find out the solution of another problem. Another problem is x square. Another problem is limit x tends to 0, limit x tends to 5, x square plus 4x minus 15, 45 upon x square minus 25. So we have given limit is we have given limit is limit x tends to 5 upon x square minus 25, x square plus 4x minus 45, x square plus 4x minus 45, and we can evaluate this limit by putting, so we first of all we check that either it is in any indeterminate form, so put x equals to 5 in numerator, then this becomes 5 square plus 4 into 5 minus 45, and this equals to 25 plus 20 minus 45, and this is 45 minus 45 equals to 0. So in denominator 5 square minus 25 is 25 minus 25, this is also becomes 0. So we have shown that this limit is 0 by 0 indeterminate form. So we factor numerator and denominator, limit x tends to 5, and this can be written as x plus 5 into x minus 5, since we have using this formula a square minus b square equals to a plus b into a minus b. So and this this becomes, again we can factor out this x square by breaking the middle term. The middle term can be written as 9x minus 5x minus 45, and this can be written as a limit x tends to 5 x plus 5 x minus 5, and this is x plus 9 into x minus 5. So this get out cancel, and we are getting that limit x tends to 9 x plus limit x tends to 5 x plus 9 upon x plus 5, and we have seen that this is not in any indeterminate form, so we can put the value of limit directly and get the value of limit. So 5 plus 9 and 5 plus 5, so this becomes 14 upon 10. This is 7 upon 5. This is the value of limit. Again we are moving on another problem. The another problem is limit x tends to 0 1 upon x plus 8 minus 1 upon 8 upon x. So we have another problem. A limit x tends to 0 1 upon x plus 8 minus 1 upon 8 upon x upon x. So by putting the value of x equals to 0, we are getting 0 upon 0 indeterminate form. We can check here, this is 0 by 0 indeterminate form. So we first of all we remove this indeterminate form. So limit x tends to 0, and this becomes 8 minus 8 plus x upon 8 into x plus 8 upon x, and this can be written as limit x tends to 0 minus x upon 8 into x plus 8 into x, and this x get out the cancel, and this becomes limit x tends to 0 minus 1 upon 8 into x plus 8. And we have seen that this is not in any indeterminate form, so we can put the value of x to get out the limit directly. So this becomes 0 plus 8, and this is minus 1 upon 8 into 8, and this is minus 1 upon 64. This is the value of limit. Again we have another problem is limit x tends to 0 10 sin x upon 6x. So we have another problem, limit x tends to 0 10 sin x upon 6x. We know that 10 upon 6 is a constant, so we can get outside the limit because x is the variable here, so we have to do anything with x only. And we know that limit we have earlier seen that we have formula limit theta tends to 0 sin theta upon theta equals to 1. So what is the condition of using this formula? The condition of using this formula is the angle in here and the angle in here must be the same, and this angle must tends to 0, and we are looking here that theta tends to 0, so the x is the angle here and x is also angle here, and this angle also goes to 0, so this can be equals to 1, and this is 5 upon 3. So we have found the limit of the given problem. Again we have some problem. We have problem are determine the limit graphically if it exists. So we have seen that we have to find out the limit given, by graphically method. So at x equals to 0, in the right side the value of the function is also x 0, and in the left side this is also at the 0. So this value limit and the graph is continuous, so limit x tends to 0, fx equals to f of 0, and this is equals to 0. Again we have to find out the limit at x tends to minus 1 upon 2. So minus 1 upon 2 is here, minus 1 upon 2, at minus 1 upon 2, at minus limit x tends to minus 1 upon 2, plus in the right of the minus 1 upon 2, the value of the function is the value of the function is minus 1, and this becomes minus 1, the limit becomes minus 1, and then left of the minus 1 upon 2, this is also minus 1 upon 2, and this is also minus 1. So we have seen that LHL, RHL and LHL are equal at x equals to minus at x tends to minus 1 upon 2, so the limit is minus 1. Again we have another problem, limit x tends to 0. We have seen that the graph has breaking point at x equals to 0, so limit does not exist at for x equals to 0, x greater than 0, the equation of fx equals to x, and for x less than 0, the fx equals to minus square root x. So limit x tends to 0 plus fx equals to limit x tends to 0 x, and this becomes 0. Again limit x tends to 0 minus fx equals to, and this is limit x tends to 0 minus 0 square root minus of square root x, and minus of square root 0, and this becomes minus 1 into 0, and this is equals to 0. So LHL and RHL at x equals to 0 is 0, so the limit is also 0. Again we have find out the limit in this problem by graphical method. So at limit minus at x tends to minus 1, so at x equals to minus 1, limit x tends to minus 1 minus, this is the minus 1, and the value of the function is minus 2. So this is limit x tends to minus 1 minus is minus 2, and this is equals to minus 2. So this is the limit, and the limit x tends to minus 1 plus, at the right side of the minus 1 plus is in the right side the value of the function is the minus 1 right side, the value of the function is minus 7. So this is fx, and this is equals to minus limit x tends to minus 1, and this is equals to minus 7, and this is minus 7. So limit at right side of the minus 1 is minus 7 by graphical method. So in the right side we are looking at here minus 1's right portion is here, so this is the minus 7, and again in the left side of the left side means minus 1 minus, so left side, in my left side the graph is at minus, minus 2, so this value is minus 2. So if someone ask you that does limit exist at minus 1, we will say that, we shall say that the limit does not exist at x equals to -1, because the limit, the left hand limit and right hand limit is not equal, since left hand limit is equals to -2 and right hand limit at x equals to -1 is -7. So the limit does not exist at x equals to -1 for the given graph. Again, we have to find out the limit x tends to 2 minus. So we find out the value of the function in the left of the 2. In the left side of the 2 is the function is 4. In the left side of 2 is the function, the value is 4. So this limit becomes 4. In the right side of the value, in the right side, the value of function is, right side of the 2, the value of the function is -4, and this is the -4. So again, in problem number 22, and also we can say that the limit does not exist at x equals to 2 in graph 21. Again, the problem number 22, we have to find out the left limit at 2, x equals to 2. So this is the x equals to 2, and we have to go to the left. Left means this side. So in the left side, the value of the function is, in the left side, the value of the function is x equals to 2. So this is the limit x tends to 2, and this becomes 2. Again, we are going to discuss about the given limit here. Integer function, greatest integer function. This is the greatest integer function of x. This is the largest integer. This denotes the largest integer less than x. This denotes the largest integer less than x, and it always takes the integral values. So limit x tends to 4 minus, and this integer part of x, we can write it as a limit h tends to 0, and this can be written as 4 minus h. And what is the value? This is the value of this value lies between the less than 4 and greater or equal to 3, and this is equals to 3. So the limit of this, the left hand limit x tends to 4 minus greatest integer function of x equals to 3. This is the answer. Again, we are going to solve this problem, exercise 28. 28 is 20th problem. Limit x tends to -8 plus, and this is the integer of x. Integer of x means greatest integer function. Greatest integer function can be written as is written as this way. And what is this? This denotes the smallest greatest integer less than x. This shows that greatest integer less than x. So we can write limit as, we have notation -8, and this can be written as, we have to go to the right of the x. So this can be written as, this can also be written as limit h tends to 0 or -8 plus h. We replace x by 8 plus h, since x tends to -8 plus h. Since x tends to -8 plus, so h tends to 0, and this is the required form of the given limit. So what is this? This value lies between the -8 to -7. So this is the this value lies between the -8 plus h lies between the -8 plus h lies between the -8 to 7. So -7. So the limit of the given function is minus 8. So we have find out that the value of the limit is minus 8. Again, we have some problems. The problems are we have the problem based on algebra of limits. What are the algebra of limits? The algebra of limits are algebra of limits. If limit x tends to c fx equal to L and limit x tends to c gx equals to m, then first limit x tends to c fx plus minus gx equals to limit x tends to c fx plus minus limit x tends to c gx, and this is equals to L plus minus m. Again, the second limit x tends to c limit x tends to c fx into gx is equals to limit x tends to c fx and limit x tends to c gx, and this can be written as L into m. This is the value of the limit. So again, we have another situation. Limit x tends to c fx upon gx equals to limit x tends to c fx upon limit x tends to c gx, and this equals to L upon m, provided m is not equals to 0. So this is called the algebra of limits, and we are going to use this definition of algebra of limits in finding out the limits of given problems. So we have given that let limit x tends to 3 fx equals to minus 4 and limit x tends to 3 gx equals to 9. So this is equals to limit x tends to 3 fx minus limit x tends to 3 gx. And what is the value of limit at x equals to 3 for fx? This is equals to minus 4, and this is equals to 9, and this equals to minus 13. So the limit of this function is minus 13. Again, we use the algebra of limit here. Limit x tends to 8, this can be written as limit x tends to 8 fx, and this limit x tends to 8 gx. And what is the value of limit x tends to 8 fx equals to minus 7, and this is minus 6, and this is equals to 42. So again, we have given that since a limit x tends to 9 fx equals to 100, so limit x tends to, since this is a square root x for x equals to 0 greater than 0 is a continuous function. So we know that a square root of x for x greater than 0, this is a continuous function, and the graph of this function is a continuous function. So limit x tends to 0 plus the square root x exists, and limit x tends to if limit x tends to fx exists, then a square root of fx also exists. And in the given problem, limit x tends to 9 fx equals to 100, so limit x tends to 9, a square root fx can be written as a square root of limit x tends to 9 fx, and this is equals to a square root of limit a square root of 100, and this is this equals to 10. So value of this limit is 10. Again we are looking here that the function changing its value at x equals to 0, and we have to find out the value of the limit at x equals to minus 4, and at the minus 4 the function is f at limit x tends to minus 4, and the at x equals to minus 4 the function is equals to x square minus 2. Why? For any x less than 0 the function is fx equals to x square minus 2, and we know that minus 4 is less than 0. So minus 4 is less than 0, so we use the definition of function here. So this equals to minus 4 of a square minus 2, and this is 16 minus 2 equals to 14. This is the value of limit at x equals to minus 4. So we have solved some problem in this series. Again we will meet with another problems, some tough level problems. So this is these limits are useful for board exams. So thank you.